Okay, so last lesson we talked a little bit about scale factors, and today we'll look more at how to calculate linear scale factors of shapes. So quickly, just pausing this video, writing down our learning intention for the lesson. So with linear scale factors, last lesson we talked about using them in construction, in architecture, and sort of blueprints and those sorts of things. And another common use for scale factors that we didn't mention last lesson was with maps. So this is something that everyone has seen before. Our little scale down the bottom there tells us how large the area is that we're looking at. So when it comes to calculating linear scale factors, if we just look at these two triangles here, this pair of triangles, we can see that they're similar. Okay, so this is, in maths, this is how we indicate that a pair of objects is similar. We write, and this reads, triangle ABC is similar to triangle DEF. Okay, so the little squiggly line means similar to. So remember we were looking at ratios, we were looking at proportions, and if we calculate the ratio between the corresponding side lengths, we get that DF to AC is 30 to 10, which simplifies down to 3 to 1. And because it's similar, all of the ratios for the corresponding sides will be the same. So if we're looking at linear scale factors, we get that over here, it's for these two particular triangles, that the linear scale factor is 3. And we always use K, the letter K, when we're talking about ratios and proportions, so just bearing that in mind. So when we calculate the linear scale factor K, all we have to do is take the length of the image and divide that by the length of the original object. So for the two triangles we were looking at on the previous slide, we get that the linear scale factor is K equals 30 divided by 10, okay, which will be the same as any of the other corresponding sides, and we get that K is 3. Yeah? And that means that the triangle has been enlarged. Little note on the bottom here, it would be good to copy this down. The linear scale factor greater than 1 indicates enlargement, so here we have K equals 3, it's been enlarged, it's bigger, and a linear scale factor of less than 1 indicates reduction. So if we calculated the linear scale factor to be, say, 0.5, that would indicate that the image is smaller than the original object. So when we're calculating the linear scale factor, there's a couple of simple steps that we follow. Write this down. It's very straightforward. We're going to look at a couple of examples. So the first example we'll look at is question 1C from your textbook. Having a look at this, it says calculate the linear scale factor for the pair of triangles. So over here, we haven't been told that the triangles are similar, so what we need to do is write that K equals, and then look at a pair of corresponding sides. So here I've chosen to look at the shortest two sides, just so that I can keep track of which corresponding sides I'm looking at. So I've just chosen to go with 4.55 divided by 3.64 as my first one, and making sure that that ratio is equal to the ratio of all of the other pairs of sides. Okay, so going through and calculating each of the ratios, we get that they're all equal 1.25. Okay, so our last step is just to state the answer. The linear scale factor is 1.25. So the next example we're going to look at is question 3a, and it says to calculate the unknown side lengths in this pair of similar shapes. Okay, so the first unknown side that I can see is y over here, and because we've been told that this is a pair of similar shapes, we know that y is going to be equal to 2.8, which is the corresponding side, multiplied by k, which will be our linear scale factor. Our other unknown is x down here. Okay, so looking at our corresponding side over here, 4.2 has to equal x times our linear scale factor k. Okay, be really careful with where we place our unknowns x and y in these equations. And I've just labelled them 1 and 2 so we can keep track of them later on. Okay, so to calculate what x and y are, we have to first calculate our linear scale factor of k. And because, again, we know that these shapes are similar, okay, so we don't have to calculate the ratio of all of the sides because we know that they have to be the same. We've been told that they're similar. So I've just picked 8.4 and 2 as one pair of corresponding sides, and I'm going to use them to calculate the ratio. And we get that that simplifies down to 4.2. So our linear scale factor here is 4.2, and we can use that in our calculations. So just subbing k equals 4.2 into our first equation, we get that y equals 2.8 times 4.2, that gives us 11.76 units. Remembering again, this says here, calculate the unknown side lengths, so we need, because this is a side length, we do need to add our units in there, because we don't know whether it's centimeters or meters, it doesn't tell us, we just need to write units. So calculating x, we again just need to substitute k equals 4.2 into our second equation, and we get that 4.2 equals x times 4.2. Okay, and to simplify, to solve for x, we need to divide both sides by this 4.2 to get x by itself. And we end up with x equals 1 unit.